25 years. Chonghan, 10 years. So, 2025. Okay, Jia 10 years. I label for you. 10 years. Okay. So other people, so that you put this one now, the function just now, in order to generate the graph. Simulated population. Okay, so we continue. Okay, so to get a sense of how much the results vary, we can run the models again, you see, several times and plot all the results. Okay, so yes, so you run many times. Okay, so you need to add a for loop here. So for I in range, iteration. So this one is the same. We can copy from here. Results. Run simulation. Here. You can copy this one. Result equals to run simulation system update function. And then you plot. Plot results. Okay, so this one you can choose your favorite color. Okay, I want to put green. I want to put red. So you just put your favorite color. Line width. This one you can change color, change the line width. So that I want it to be a little bit thick. I put 6. Let's try and see the graph first. Okay, so you see, it's important for you to do the coding instead of copy and paste. So you copy and paste, you cannot, you are not aware. So when you live coding, you know that for Python is controlled by the tab. So for must have a tab. Because Python doesn't have the bracket or curly braces or whatever, so it use a tab. So the expected tab, indented block after the for statement. So this one, the plot option alpha equals to 0, 1 makes the line semi-transparent, so they are darker. Later we change. So we can change to 0.2, 0.3, and the run plot many simulation with your update function. This one is iteration equals to 30. Also plot the original data. This one you can crop. And anyway, this one this one is the block comment. If you want to copy the block comment, also can. If not, then you just copy the code, or you can crop it, or you can screenshot the code. If not, I will move it down. Then later you cannot see. So that we do the plot. Just now we want to do the iteration is equal to 30. These are all the parameters. Later you can change. Plot many simulations. Okay. 30, I do 30 first. Later I change. Okay, so I start seeing my plotting now. Okay, so I start putting my my graph now. So you see that the original one, estimated population, this one original one is always remain. So now, okay, never mind. I will have this one first. I copy. So this one is my first run. So using my parameter, okay, I would like to have a few. 20 years. Wow, this one become endangered species. 25. 2024, 25 years. Wow, 10 years. 20 years. 10 years. Wow, this one is how many years? Okay, so we continue. So this one is our new plot. So I put a line here. Okay. So there are a few plot. So I book my name first. So that these are all mine. I want to change the parameter and I want to have many plots. Okay, I have 3 more. So I put my name here. Okay, everyone get the code. So you need on just now was here. So you need only to have this function plot many simulation. You need to have this one plot many simulation followed by the plot many simulation. You run. So this one is that you create the this one you create the function, and then this one is you run the function with the parameter. Okay, now I want to have fun now. So I change my color, change my line width, change my iteration. So I just copy. Or I don't need to copy. I'll change here. I just want to get the different graph only. So the next one, I want it to be blue. Line width 3 enough. And then alpha, let's see 0.2, what happened? 0.2 makes line semi-transparent. So iteration, I change to 20. We don't know what happened. I just change first and see what happened. Like that, much clearer. So you see that I changed the line width to 3, much better than 2. Okay, so I copy. I put here. See, much better now. Junhong also use blue. So that I want to have one more. I book my name already, so I want to have one more image. So I will change my red, blue, green. So line width, I change just now 6. So now 3, I make 2. So alpha 0.4. And then the iteration, I change it to just not 30. I change to 50 and see what happened. Okay, this is what I get. It seems like I look better than the first one. I plot all three, then only we can see. So 2020 152535. So this one is based on my 20 years. This one, so it depends on your year. So Junhong stopped at 10 years just now. So yours still at 25. Mine is at 35 already though. Okay. So Chia Yi also 35, 35, 35. Wow. You see that the different width. So that, wow, you see that the last one, I think that the thinness looks better. The first one cannot see also the red color one. Pang, Junwei, okay, Elderick. Wow, Elderick 40 years. You see, when you predict, it become like that. So this one is Elderick. So now we label it with the pink color. Eugene. Okay. So you make 3. So this one. This is Xingjie. Xingjie also changed many. Wow, what is this? 2040 is like that. Interesting. Okay, come. We continue. See what else can we do. Okay, so you see that the next one. So this is how you can. This one is now you can feel the population. This one the simulation. So it is simulation. So others you must get up to here, because when we continue, you don't get a code, then you cannot continue. So you must, we are now at the plot many function, the definition of plot many function, and then we run the solution many function. Okay, now we want to see, you see that there are some explanation here. So you see that it says that the results are highly variable. So according to this model, the population might continue to decline over the next 10 years, or it might recover and grow rapidly. It says that it might. So that's why we got the graph up and down spiking. You see, because this one is a simulation with the random number. So it may happen up and down, unpredictable, you see? Okay, so it's hard to say how seriously we should take this model. And there are many factors that influence salmon population that are not included in the model. So this is the one that I want to elaborate and include a little bit for your project. You see? There are many things. You say that the comic vista, the line, and then there are many factors not considered in your simulation. You say that there are what? The weather and many things. So same like this one. You see, our simulation of this salmon just now, we did not include all this. So we don't know what may happen. So for example, if the population start grow quickly, it might be limited by resource limits, predators, or fishing. So if population start to fall, human might restrict fishing and stock the river with farm fish. They need to do the simulation in order to ensure that you have sufficient supply of the fish. So like this is what happened in the recent Fukushima. This one, the radiation, when they release the treated radiation from the radio, this one, the plant, the nuclear plant. So that immediately when China banned the import of the fish from Japan, then it has an oversupply. Oversupply means that the fish are more. but they cannot export the fish to China. So all the farmers in Japan, they suffer. So, but they get the compensation from the government. This is how they control. So they do the simulation to control. Very good, when you do the simulation, then you can put when the fish is more, how. So this is a purpose for predicting the demand. Okay. So this result should probably not be considered useful prediction. This one just now, as you can see, they are not useful. We don't know how and what to use for this one. Okay, there might be something useful we can do. So we want to do something on the simulation now, which is to estimate the probability that the population will increase or decrease. So we want to increase the probability. So just now was totally unpredictable. So now we want to predict it in such a way that it may be increased 0.2% or it might decrease 0.5%. So we add the probability now. Okay, so here is the distribution of the net change. So what we're going to do now is that to describe the distribution of net change, so we write a function called run many simulation. Yes, run many simulation function is already here. That run many simulation. So save the final population in MoodSim series and return the MoodSim series. So same as just now, you run many times and you get many results. So for this one, for the definition for the system, again, we have our block comment here. Run simulation and report final population. And our parameter here, system refer to the system object, update func refer to the function object, and iteration refer to the number of simulations to run. So just now I use up to 20, 35. So this one, I try to number of simulations, iteration. Wow, just now I iterate 30 times, 20 times. So this now I will reduce it. Okay. So here, fill this in. So you can write the run many simulation. You run this one here. So for the last population equals to MoodSim. So we include one for loop for I in range iterations. Okay, so you see the iteration was on the earlier function. Later I'm going to change my iteration now. I don't want to use so many times already. So reduce it. Okay, so you see that when you enter, it was directly have a tab here. Okay, you try to run first and see what happens. No error. So this function is correct. Okay, so test your function with the iteration equals to 5 here. Okay, so this is the value. So no error. So the function is correct with the testing the function with 5 iteration. Okay, try to get the function correct first. Okay, done. So you can open one notepad. So you copy the screen, you paste in the notepad so that you can refer, so that I can move my screen. Or if you want to make it fast, all these block comment no need. Then you can having a lesser code. Okay, so I continue. You copy, you crop the screen. Okay, now I continue. Okay, so now you run 1,000 simulations and describe the distribution of the result. So you see that I put an x here. So because I want to run 1,000 simulation, so I change this parameter to 1,000. So I use the describe. So describe is only applicable to the numerical value. So it will show the statistical describe for the count, mean, standard deviation, minimum, maximum, 25%, 50%, and 75%. So this is when you want to describe any of the columns. Because I run 1,000 times, so that you can see that it takes long. So later you can change it. So this is 1,000 simulation. Change it to 200 lah, faster. See, it's still running because of the 1,000 simulation. No more. Okay. So it count 1,000. Yeah, I can just change to 200 and run again, see what happens. It will be much faster, or even 100. See, when I count 100, it will be much faster. So now I put back to 1,000 and then run again. So it's running. Okay, so this one is to show you that it will take long to run. Okay, what happened next? So if we subtract off the initial population, so we will get the distribution of changes. So you subtract means that you minus. So P is for population, P0 is the beginning population. So the net changes is the last population minus initial population. So this is the description again for the net change. So you can compare. Definitely the mean value will be lesser because the mean is the average. So now you minus off the initial population. That's why your mean become lower. And also that the value are different, because there is a random variable that we involved just now. And others are like the median is negative, which indicate that the population decrease more often than increase. So we can be more specific by counting the number of runs when net changes is positive. Okay, so we want to avoid the negative value. So we put here some net changes more than 0. So we only get the positive. Everyone will get a different value, because just now some parameters that we use, and also due to the random value. Or we can use the mean to compute the fraction to run where net changes is positive. So we use the net fraction. So you get a different, everyone get a different value. So this one is a net changes. Okay, so based on observed past changes, so far we have seen that the model predict the population is more likely to decrease than increase over the next 10 years, about 2.1. Okay, so we read from here, 0.311 compared to the, you just compare the value for the last population and the net changes. So that we do it. Okay, so usually it's like that. So all the exercises, the first one, we do the rough one without any detail so that we refine it to make more detail by including more parameters. Okay, let's see what are we going to do. So in order to have a better workable model, what we can do is there might be a cyclic behavior in the past data. So with a period of 4 to 5 years, we could extend the model to include this effect. So this one is part of your project. Your project also can do like that. So the one that I give you was the template. This one that you can extend the model. So you study what will be the effect. Then you have the section, a refined model to make it better. So let's say your initial, the Q not very nice, then you can refine it to make the Q better. Okay. So this one, the first way is by extend this to include this effect for the cyclic effect, cyclic behavior. And the second way that we can do is for the older data might not be as relevant for prediction as new data. So we can give more weight to the newer data. So you can take a look back to our report just now. Oh, you see that back to 1997. And then we want to predict for the next 30 years, 40 years. So this might not be a good idea. That's why we want to use more newer data. Okay. And then this one is the first one. And the second opinion is easier to implement. So let's try it. So use the line space, which is to create an array of weights for the observed rates, and the probability that we can choose each rate will be proportional to this rate. Use the line space to create an array of weights. Okay, the weights have to add up to 1. So divide directly by the total. Okay, so that we try this one. Follow the weight using the weight. Okay, so we do the plotting. We plot the weights. Then we put in, you see, what happened if you don't put the, so that this one,